Is on expanding logs. So expanding logs is basically putting this into a bunch of logs because right now it's a condensed log, as you can see. So one thing I wanted to clear up, if there's exponents and like stuff in logs, whether multiplied by each other, like say you have log times xy, this would become log x plus log y. So yeah, if that's what happens when you're multiplying, if it was like log x divided by y, this would be log x minus log y. That's basically what it means. So, and then last thing, if you have log, let's say x squared, then the exponent goes log x, it goes to the front, and it becomes 2 log x. So that's basically like changing logs and stuff and expanding them. That's how showing you all the rules. So let's put it into a problem. So log 100x squared y. So this division, so let's go one at a time. So you see these are all multiplying by each other, the 100x squared and y. So we can, since they're all multiplying by each other, we can just add them up, right? Over here, we said our rule is that times that, it would be that plus that. So log 100 plus log x squared plus log y. And then here, we can worry about this division later because you see how you have to subtract it by like this whole thing. We'll work it later because it's all bunch. So anyways, here, are we all completely expanded yet? No, we have an exponent here. So this goes down log 100, that's saved. The exponent, remember we bring it to the front like we did here. So then it's plus, remember they're always plus, 2 log of x. And then this log y stays the same, there's no exponents or anything. Log y. So we got this whole part simplified out. So now divide by z to the third. So remember when we said divide, it's subtracting. However, we're subtracting this whole thing. So let's put all of this logs. And then we're subtracting it because we want to make sure these are all added together and stuff. And then it's divisible, divided, or subtracted by log z to the third. However, we're not done. You see, we got that exponent. So now we got log to the 100th plus 2 log x plus log y. And I'm just putting the parentheses to make it more, make it more organized, minus, and then we move that 3 to the front. So then it's 3 log to the z. And then look, there it is expanded. Expanded, it's log to the 100th plus 2 log x plus log y, all in parentheses, because you want to add all of these up, like over here. You want to add all of them up, because that's what all of this is. And then divide by 7 to the third power, which is minus 3 log z. So you want to make sure all of these add up or whatever, so that you get that log 100x squared y. And then divide it or subtract it by 3 log z. So the summary of this is that in logs, whenever they're multiplying, to expand them out, they're actually adding. So if it was like, let's say, log 100x squared y, it's actually log 100 plus log x squared plus log y. And then also you have to watch out for the exponents, because for exponents you have to bring them to the front and then make them a coefficient of it. Like here, log x squared is 2 log x. And then for division, you always have to make sure for division that well, it's subtracting, so yeah. And, well, yeah. That's basically what it is. I mean, honestly, you don't really need the parentheses because since it's all multiplication and division, there's no, parentheses over here except for those outside ones. So I guess technically, I just wanted to write it out better. But you don't really need those parentheses. But you have to know, mainly, that it's log 100 plus 2 log x plus log y minus 3 log z. Because you got to know dividing in logs is subtracting, multiplying in logs is adding, and then the exponents in logs, you shift that over to the coefficient, the leading coefficient of whatever that term is. And yeah, you got to know that for expanding logs. And let's go through another example. Just an example. Log 3 root x divided by y. All right, so we know multiplying, we have to add them. So we know these two are multiplying, so it's log 3 plus log square root of x. So you see the square root of x, you're like, what the heck, man? And of course, divide by y, so that's subtracting. Division is just subtracting, so that's just minus log y. And again, you're like, what the heck, man? Why'd you put square root of x? What does that mean? Well, if you remember, the square root of any number like x is the same as just x to the 1/2, remember? So we can change that into an exponent. So instead, we can just make this and change it into log to the 3rd plus to log to the x to the 1/2 minus log to the y. You see? It makes sense. The square root of x is the same thing as x to the 1/2. If there's a cube root of x, it would be x to the 1/3. You get it? So on. So then, you see the 1/2, what do we got to do to it? We got to switch it to the front. Nothing else needs simplifying, but we got to switch that to the front. So now, let's write this all out here. You got your log to the 3rd plus your log to the x to the 1/2. That 1/2 comes to the front, making the coefficient 1/2 log to the x. And then subtract log to the y. And there, boom, you get your your expanded, what am I saying? Your expanded log, which is log to the 3rd plus 1/2 log x minus log y. And the main things you got to take away from this video for expanding logs, in logs, if they're multiplying, you're adding them into individual logs. If you're dividing, you're subtracting them into individual logs. If you have an exponent, you bring it to the front of the log. And if you have a square root, the square root is the same thing as a fraction exponent. Like in this case, x squared. The square root of x is x to the 1/2. You could have other cases like x to the cube root, the 4th root, and then the 5th root, blah, blah, and it would be 1/3 for the cube root, 1/4 for the 4th root. You get the idea. So yeah, that's basically all. You got to make sure your exponents are flipped to the front to make a coefficient, like here, x to the 1/2, because its square root of x is x to the 1/2, basically. And that 1/2 comes to the front, so it's 1/2 log x. And yeah, that's expanding logs.